Well, thank you, Elena, for that wonderful introduction, but I think we should maybe have you both introduce yourselves and explain a little bit more in detail what you guys do. So let's start with you, Trent.
All right. Hi, everyone. I'm Trent. Since the late 90s, I've been doing AI for various problems, defense, computer chip design, creative design, and all of this. And about 5 years ago, I got into blockchain pretty deep and pretty heavy, doing IP on the blockchain, digital art, this sort of thing, with a project called Describe. With that, this was 2013, we ran into issues of scale. We saw that Bitcoin, people said it's bloated, what the heck, but it only was 100 gigabytes, right? And any of you, and this is data natives, we should know data, calling something bloated when it's 100 gigabytes total, it's not bloated. It just means there's a failure in the design of the underlying technology. So we decided to leverage all the great ideas coming out of the big data, the distributed database space, et cetera. And that's what led us to build BigchainDB, scalable blockchain database. And so we've been spending a lot of time with that, rolling out a public network called IPDB. And more recently, something called Ocean, which sits on top. It's a substrate for a new data economy. So really the focus is 2 public nets, IPDB, scalable blockchain database network, and Ocean, a new data substrate for a new data economy. I'll leave it there.
Okay. Well, thank you very much, Trent. And Andreas?
All right. Hi, I'm Andreas. I'm from the IOTA Foundation, where I'm a core developer. I've been in the software engineering space for a couple of years, and only recently became deeply invested in the whole cryptocurrency area, or rather distributed ledger area, actually. So what IOTA does is essentially we were founded in 2015, when our founders also realized, blockchain or well, traditional blockchains don't necessarily scale. However, if you want to have this system in the future where you can have machines paying each other and all of this at a very high scalability, then we need another solution, and that's where we came about. And we're quite different from traditional blockchains, and our structure is also quite different. But our main selling point, so to speak, are that we're enabling or hoping to enable machine-to-machine payments in the future, and also all of this without anyone having to pay any fees.
Okay, fantastic. Thank you very much. I want to kick off with two quick audience surveys. The first survey, who really knows what blockchain is? Hands up. Okay, so it's going to be interesting for the audience, at least. That's good. Second question is, I love Andreas's accent. Who thinks he's Australian? Hands up. Who thinks he's English? Hands up. Who thinks he's German? Hands up. Okay, those people know him, that's why. He's German, right? His brilliant accent. Given the number of hands that have been shown and your guys' expertise, and the name of this talk, What the F is Blockchain, why should we care about it? What is it?
All right, so what is a blockchain? It's essentially well, the name's quite revealing. It's blocks being chained next to each other, and each of these blocks represents a certain number of transactions that are happening that can either encode value transactions or that can code even data as part of the value transactions. Why should we care about this? So the easiest answer to this is that the core property of blockchains is that the longer the chain becomes, the harder it becomes to actually change what's happened as part of this blockchain in the past. So you might have heard about Bitcoin and the whole mining stuff. So what's happening here is that these miners have to solve very hard cryptographic problems, or they have to find collisions of hash functions, essentially. And by doing so, they create a certain immutability, because the more blocks there are, the higher the difficulty of the total blocks becomes. So it's much, much harder to actually go back in time and just swap something out, because it's not as easy to find collisions.
All right. Yeah, so first of all, I'll say that if you ask anyone in the blockchain space what a definition is, almost everyone will give you a slightly different definition. And some of them will argue like crazy. Someone who's like really, really, really heavy into only Bitcoin will say, there's only one true blockchain, it's Bitcoin, blah, blah, blah. Myself, I have a much more pragmatic view. And your definition is actually as good as many, so thank you. in the world of AI, you could say AI is this or AI is this, but a very pragmatic definition for AI is simply a field with a whole bunch of interesting tools for regression, classification, et cetera. There's themes, there's visions, there's values around that field. I see the same thing for blockchain. It's a field. It's a field that has a collection of tools, challenges, ideas related to decentralization, related to power to the people. And within that particular field, there is an emerging stack. So just like in the 80s we had the desktop stack, and in the 90s we had the early web, in the 2000s we had the late web stack, then the cloud and the mobile stack. Each one of these stacks has different building blocks, right? You've got file systems, you've got databases, you've got processing, you've got platforms around them. So in the cloud stack, Amazon instantiates one version of that, right? Where you've got S3 for storing files, MongoDB, for example, is a database, or maybe DynamoDB. Et cetera, et cetera. Well, in the world of blockchain, in the field of blockchain, we have an emerging stack as well, where there's these decentralized computing components for file systems, things like IPFS and Filecoin or Swarm. For databases, things like BigchainDB. For processing, decentralized processing, you know what that's called? Smart contracts, right? It's got a fancy name, but that's all it is, decentralized processing. There's a stack around that. So to me, that's really the way to think about this overall, and it leads to very pragmatic implementations as well. So that's the best way to think about this. It's this emerging compute stack with particular benefits, decentralized control, which sort of acts then like a public utility. No single entity owns or controls it. You've got immutability, so that you've really great trails of provenance, whether it's for financial data or art or whatever. And you have the idea of tokens or assets, where these things can fluidly exchange from one person to the next. And you can use tokens to incentivize people to do stuff. So those are the main benefits. There's tons of cool applications emerging. I'll stop there.
No, I thought that was a very, to use your word, pragmatic description of blockchain. Following from that, the blockchain is very hyped at the moment. May I be devil's advocate and say potentially overhyped at the moment? I read just recently that some publicly listed company, I think in the US, added blockchain to its name, and its equity price quadrupled instantaneously. Every website, all the website I see, rather than saying that it solves a problem, nowadays just has the word blockchain put in big capital letters, and that seems to be everything I need to know. Here's my issue, which I'd like to hear from you. What has anything really substantive come off of the blockchain aside from Bitcoin and Ethereum? What is it actually doing? People have been talking about it for a long time. Can you give me some concrete examples of how it's adding value?
So I think leaving aside the actual value of a token on the blockchain or whatever, the main offer for companies, for enterprise users, is a matter of trust. With blockchains, because these chains are immutable and you can't just go back and change things, you can also right away trust into a system that no one is fully able to control. So take the audit scenario where you're doing something in the public space, but every couple months or so you've got an auditor coming from the federal government who of course doesn't trust you. Now what this auditor usually does is they're going to ask you for data, and then they're going to have to trust your data. And of course you could just change that data so it doesn't represent what actually happened. Now, the thing that blockchains gives you in this context is that all this trust issues suddenly becomes a matter of, you can trust me because I can't change things. And I believe that that is what most enterprise users at the moment are looking for. Simply, trust is no longer something that you control. That's probably the core value of blockchains.
Okay, Trent, could you expand on that and give me maybe a few concrete examples where this has been implemented and is being utilized?
Yeah, so my pleasure. I've always broken it down that there's 3 new benefits above and beyond existing systems, and that is decentralized, immutable, and tokens or assets. And I kind of covered that before. Decentralized, where you're spreading power among many more people, it acts like a public utility. Immutable, where it's you've got provenance and other applications, and assets, where you can have these tokens that exchange in low friction to each other. So I'm going to talk what we have. We've iterated with hundreds, probably thousands of organizations by now, and we've sort of pattern recognized what are the most valuable and useful use cases. And there's about 6 or 7 verticals that really emerged. I'll focus on 4 quick ones: identity, IP, supply chain, and financial. So in identity, this is the idea of reclaiming your personal data, the idea of sovereign personal data. A very simple one is KYC. So there's a company, a Tim Draper-funded startup called Authentic that we work with, and they basically provide KYC services where all the personal data related to KYC is held client-side, and then our public net, IPDB, acts as a broker towards using those services in various contexts. So that's, and there's a lot of different identity-related things that are within that space: healthcare data, website login, et cetera. So that's identity. IP. The main idea there is how do you manage the transfer of intellectual assets? This is sort of this intangible thing. This is where we started in the world of digital art. There was this big elephant in the room question: how do you collect digital art? So this overall art industry is a $64 billion industry, yet less than $500 million was in digital, which is kind of weird given that we're in this, living in this digital era. You can solve that by saying, what if you could own digital art the way that you own Bitcoin? It turns out that that's a really strong foundational approach. You can track the provenance, the history of ownership of these art pieces all the way back to the creator, and then you can truly own a piece of art, a limited edition, et cetera, et cetera. So that's the second. It unlocks basically art and music and all of these other IP fields. The third one, supply chain. It's kind of similar, but it's about provenance of actual atoms. When you take a pill, how do you know that that pill bottle wasn't tampered with? When you drink a beer, how do you know that that it's coming from the place it came from? A few years ago, Bauer was manufacturing hockey sticks out of China, and the Chinese factory decided to put in cyanide into the paint simply because it was cheaper, right? And if you actually had much stronger provenance, that would have never been an issue. So overall, tracking of the provenance of actual atoms can improve safety, as well as save costs and fraud and many other things. Finally, in financial, I'll give 2 very strong examples that have emerged as 2 of the things that blockchain has already disrupted. One of them is VC financing. In the last year, there's more than $3 billion that has gone into ICOs. Whereas in terms of seed and early stage investing of VC, it's about half of that. So you might say, well, blockchain might, in the future, disrupt VC. The answer is it already has disrupted VC, and this is just the start. So that's one example. Another example in financial is remittance, the idea of transferring money from one institution to another. Every step along the way, you have to pay about $10 to $20 for trust. So it costs you $40 or so, or euros, to transfer money from one bank account to another. Using something like Ripple, basically the cost goes near to zero. And Ripple actually is now used more broadly than Swift, which is the traditional financial network. Ripple itself has more than $14 billion on its books. So these are 2 of the biggest success cases, and these are still early stages. In the other ones, by the way, I mentioned Authentic for the ID. The IP is Ascribe is a great example, Ujo Music. In the supply chain, we're working with Energy on something called Digital Twin, and many other companies for this. So there are tons of real-world examples out there. Just because they're not famous to you doesn't mean they don't exist.
Okay, that was very good. But you touched on something very dear to my heart: finance, right? That's the world I work in. And a lot of talk goes on around blockchain and the way it's going to fundamentally change the financial services industry. You've given a good example of Ripple. I will dispute that number as to more going through Ripple than Swift, because that I just don't think is true.
Yeah, that part I agree. It's just more banks signed up. But yeah. So they're roughly par depending on how you measure. So I agree with that part.
Okay.
Yeah.
Here's one issue with financial services. And this challenges to me, the cornerstone of what both of you have mentioned around trust and a decentralized network. It appears that any implementation of a financial services-related blockchain or a government-related blockchain is also a similar issue, that this will have to be a private blockchain. private node blockchain, in which case in nearly all of the implementations that seem to be gaining some sort of traction, you have a central party managing that infrastructure. Going back to what you said before, that it's distributed control, it isn't. It's actually just a distributed database. Is it not veering away from the basic nature? As you said, some people claim true blockchain is only Bitcoin. Isn't this veering into something completely different, where blockchain is just the foundation of better things to come or other things to come?
So I would actually argue that financial transactions in this context do not necessarily need a private network. The big question is, of course, how much of your transaction metadata are you willing to expose to the public? So if you, for example, are unwilling to expose the actual amounts that are being transacted anywhere, then of course you're probably facing a problem. You can't easily do that on a public network unless you suddenly figure out how to abuse the network, if you want to call it like that, to do something else than what it's meant to do. But as for the main metadata, I mean, you can always just stay and encrypt it, so nobody other than you and those who are able, who you give the power to decrypt the data, is able to access it. So in the context of financial transactions, what could happen on a public blockchain network, on a public Tangle, wherever, is people might be able to see, oh my, somebody just sent someone $1 million US or whatever. But no one would know from where to whom, because at the end of the day, unless you start following funds and you start doing taint analysis and similar approaches, you're not going to figure out just who owns a certain amount of funds. So you are probably going to be fine with running your software on a public network. However, there's arguably very few cases where you're not, because you're not going to get around a private network because you're unable to or you're rather not willing to expose the amount of information that a public network requires from you.
Well, I don't necessarily agree that it's you, or in this case, I think you're referring to a financial institution or a private individual.
No, I was referring to a financial institution.
But with regulation coming in, which I'm sure has been discussed already here, like GDPR next year, where the control of that information is being given to us as consumers, and broader financial services regulation that talks about being able to trace and track data, which aligns with GDPR if you want to manage and control and eradicate or remove that data, as you can do under GDPR. That doesn't really fit with a public blockchain, because I don't know where that data is, because there's no public map of the public node system, correct?
So maybe let me address this. So the assumption going back has been, OK, we've got data that we don't want to be exposed, therefore we're not going to be in public, therefore we're going to be in enterprise. That was the assumptions going back a few years, based on sort of this idea of Bitcoin, which is almost 10 years old. But we're past Bitcoin. You know, that's your grandmother's blockchain, right? And in particular, there is privacy that comes in various ways. You can have privacy of the identities that are operating on this public net. You can have privacy of the transactions themselves. You can have privacy of the actual data inside the transactions. And the data itself could actually be stored client-side, if you will, rather than on this public net, right? And then with that, you can actually, related to this privacy, there's actually the idea of permissions, like you have for decades in Unix and databases and so on. We've been building these into BigchainDB because our view is, you know, when you think about a decentralized database, well, it should look, act, feel like a database too, which means permissionings and roles and all of this, right? So just build that in, rather than assuming that it has to be fully open the way that Bitcoin is. So what's happened then is a lot of these enterprises have adopted these private chains thinking this is the way to go, but you are absolutely right, right? If it's just one organization running it, it's not decentralized. And maybe you have a little bit of immutability because of one hash and the next, sort of this linked list of hashes. But you can still have this sysadmin and go and delete everything or something, right? So to me, like, the future is the public nets, especially if you have good privacy features, right? And the banks, they really hugged blockchain in 2015, and they hugged it, and they squeezed it, and they squeezed it, and they squeezed it. And now almost all of those efforts, hundreds of efforts for these enterprise blockchains in the banks, they're all dead. Almost every single one. There's very few survivors because the banks, at the end of the day, did not want to give up the control. The exceptions I mentioned are basically things that rerouted around the existing incumbents. So in the future, I don't know the strongest, like banks, the role of banks will radically shift. Maybe there will be CAs to pronounce that certain things are trustworthy. But a lot of the role playing middleman, you know, the system is going to route around that unless they get their act together and actually embrace the public chains.
But that's the conundrum to some degree, and where I've seen the stumbling blocks on wide-scale adoption of blockchain. So you talked about Ripple. Ripple is ultimately only being as successful as they are because they've managed to get the banks on board and using it. The bigger problem in the world of remittances is from a pure business perspective, which is one of the bigger barriers to larger-scale blockchain adoption in payments, in remittances. Because let's face it, I find it absolutely insane, as I'm sure most people in this room do, that I can send that monitor to Singapore with more traceability and with more speed than I can send euros to Sing dollars, right? That's insane in today's world. Digital numbers, digits, take longer with less tracking and less certainty over cost than me sending that monitor. Ripple makes a lot of sense to me. However, the problem is with the SWIFT network and what is called the correspondent banking chain, the banks all earn $650 billion a year by doing pretty much nothing. And trying to tell them you must switch and lose all that money is a difficult effort. There's all these barriers for larger scale adoption. How do you think, have you seen examples where some of these things, or, you know, I heard somebody in the audience about a month ago at a blockchain conference claim there's going to be a revolution, that the people will rise up against financial institutions and all adopt blockchain. And I kind of smiled and I said, okay, whatever you think. What do you think? How do you think we can push beyond these barriers to grasp some of these costs? You know, the EU, they actually estimated cost savings to financial institutions in the region of 800 billion a year, I think it was, by adoption of blockchain. But it's still not moving. What are these issues? Why aren't more people doing things? Why isn't it moving faster?
So leaving the crypto-anarchists' point of view or opinion aside here, I think that main issue that is preventing, you know, blockchains or cryptocurrency technologies to gaining widespread adoption is real-world use cases. Not just, you know, sure, you've got the enterprise users in terms of the banking stuff with Ripple. You've got, I mean, maybe some people heard about a house being transferred using Ethereum or something a couple of weeks ago. But at the end of the day, these are only very specific use cases. They don't touch your everyday life. You're not just going to go out there during your regular commute to work and suddenly start interacting with a blockchain. These integrations into your real-world life haven't happened yet. They hopefully will happen. We are absolutely working with a couple of companies on making this happen. But they have not. And until this has happened, I don't think that we can see that we will see this shift in the financial sector either, because up until then, you know, the traditional approach to banking, traditional approach to currency is still way more prominent.
Yeah, a couple of answers. Like, first of all, on the remittance thing. Ripple itself has, in fact, as of 3 months ago, lined up 75 banks. So whatever sales pitch they have, banks are adopting, right? And it's probably because their users are saying, we don't want to pay these 40 € fees anymore if we actually can go another way. And without the Ripple way, well, guess what? You know, Bitcoin to Bitcoin, I can transfer money to my mother in the form of Bitcoin in 10 minutes cycle time, and it can be thousands, tens of thousands of dollars. So there's remittance if you actually just work around the system, right? And then this is what's actually happening is a lot of these flows are just going other directions. So I don't believe we actually have to rely on the banking system. Sometimes these industries fade away. I think it's much healthier, though, if the incumbents figure out ways to work with the people building these tools, including even as extreme as the anarchists, right? And we see this. You know, myself, myself, I was in Estonia 2 days ago, iterating with the government of Estonia, helping to provide them guidelines on ICOs and even beyond, right? And one thing that I've discovered, the anarchists had this assumption that the laws would move slowly and the technology is moving way faster. But to get the technology scalable, it takes time, right? We're talking years. And guess what? The laws are moving much faster than anyone expected. Right? Even in the room with the Estonians, one of them was like, well, what about this problem? Oh, yeah, we changed that law 3 months ago, right? So, some nations and some jurisdictions are moving really fast, right? Singapore has recently provided even better guidance on ICO themselves. So we also iterate with Singapore and otherwise. So I think, the nations are providing guidance. The banking industry doesn't have a long-term incentive because they see that over time, their revenues are going to go down unless maybe they embrace it in some other way, right? So, but it might mean that they're dead. They might be the Kodaks of now, right?
No, absolutely. But I think also it's very interesting that a lot of the focus with blockchain, which is sometimes underplayed, is the cost savings that are there. Although a decentralized database is not quite the same as a blockchain, I still remember, and this will show my age, New York 9/11. I was at a firm where we had a decentralized matching engine. And 9/11 happened, all the exchanges went down, right? Our exchange was the fastest to come back online because we could pull the data from the nodes to collaborate that what transactions had been done or hadn't been done. All the other exchanges took about 6 hours to come live.
Quick question. Did your company control this decentralized matching engine?
Exactly.
It's not decentralized. So to be clarifying for everyone, this is a really good way of thinking about it. There's 4 levels in the spectrum from centralized to decentralized. There's fully centralized, where it's one compute resource and one sysadmin controlling it, or one organization. Then there's distributed, where you have the compute resource spread across 10 or 1,000 boxes, but still one sysadmin, one entity controlling it. This is like MongoDB. This is what you guys had. That's distributed, not decentralized. Then you have decentralized, where you actually are spreading the control and the compute, right? And this is what federation chains are and so on. And then you can actually have decentralized and tokenized, where the infrastructure itself, the incentives to run that infrastructure, are actually coming intrinsically to the system, these native tokens. Like in Bitcoin, if you're running a full node with hashing power, then you might win some Bitcoins every 10 minutes. So that's the spectrum. Centralized, distributed, decentralized, decentralized, and tokenized. And often there's confusion, but this is why I took the opportunity to really clarify.
No, that was a very good example. Yes, distributed database, but that helped in itself. And the cost saving that really translated into opportunity cost in terms of revenues was massive as a result. And there is an element here of standby and I guess the word is redundancy that's available with these distributed type databases, which seems to be ignored a little bit, whereas more of the focus is on the immutability and the trust element.
Please let me comment on that. So Bitcoin has 6,000 nodes. Guess what? Its redundancy is 6,000. That's actually, it's not ignored, it's actually complete overkill, but at the same time, it's absolutely there.
The one major success story that I have seen has been Everledger in the diamond market with the registration of diamonds. You're looking at me. Have you heard of them? No.
I'm actually not sure if I have.
Oh, Everledger are doing very, very well. So they're doing registration of diamonds so that you can trace the authenticity of diamonds internationally, and that's worked out quite well. They've scaled quite massively. We have a couple of initiatives in Luxembourg as well. We did the first blockchain-based fund management subscription as well. So there's been a big focus there. Going back to my earlier question is, if I may bring it up again, which other examples can you give of businesses that now seem to be doing quite well with a blockchain infrastructure underlying it?
Actually, take this one first, maybe.
Okay. Yeah.
It's always so hard to think of companies using this and publicly using this, and not just, I mean, sure, it's super easy to gain to gain PR because you're doing blockchain. As you talked about earlier, just add blockchain to your name and you'll get a massive rise in your assets, in your stock value. But at the end of the day, whether you're successful long term is much more difficult to say.
Yeah. So I'll give a few examples here. Within BigchainDB, we iterate with probably 40, 50, 60 companies, and we actually have a consulting arm with a team of application engineers and so on, building out POCs, taking things to production, et cetera, right? A lot of those we can't, unfortunately, talk about, but I can talk about some specific cases, ones that have been public. So one, for example, is self-driving cars. This is working with Toyota Research Institute. So in the world of self-driving cars, I'll talk more about this later in my talk, but the algorithms are there. Basically, you can actually get a car to drive along and not crash most of the time. Maybe the failure rate is 0.1%, so 1 in every 1,000 trips, right? There's a crash. But the thing is, so then from there on, what you need is you need to improve the accuracy. And what people in the world of AI have discovered, many of you here, I'm sure, is that it's a lot easier to improve the accuracy by adding more data rather than improving the algorithm itself. So you add 10x, 100x, 1,000x more data, and then you actually have the accuracy you need. So what the car companies, including Toyota, have discovered is they've calculated to get the accuracy they need about 500 billion to 1 trillion miles driven. Right? When they get to that, they can deploy these self-driving cars in confidence. Because with those miles driven, they can make their models, they can train their models, and their models will be accurate enough. And then the overall benefits are simply that you have fewer accidents, right? In US alone, you have more than 1 million deaths from driving per year. These self-driving cars can be actually 1/10, 1/100th the accident rate. It also gives more mobility to people who might not have a driver's license, et cetera. So this is something that's happening right now. It's not, we're working with Toyota, but several other auto manufacturers and the Ubers of the world, et cetera. So that's an initiative that's ongoing, but it's actually addressing a very, very big issue in this multi-trillion-dollar industry called the automotive industry, the roads, and so on, right? So that's a very real thing. These things take years to come along, right? And by the way, the core of this is getting them to pool their data so they all can amortize the cost of gathering the data. That's the key thing. And you can't really just, all of you pool and, hug and sing kumbaya. You need some sort of data exchange to transact because they're all big enterprises, right? And that's really what a decentralized data exchange or a substrate for this is about. That's one example. Another example is Nexus, which is a large energy utility in the Netherlands. We work a lot with them. We work a lot with Energy and many others. And kind of the core issue that all of these guys are seeing is we've got this deregulation coming down the pipe, right? So energy deregulation. And what does that mean? It means the middleman is going away. This is actually a perfect fit for the world of blockchain. And so with Nexus, they're working on towards basically removing themselves as the middleman and just providing support technologies on the fringes to basically make this all flow in the future. So there's a phase 1 we're doing right now, then a phase 2, and so on. And phase 1 is actually towards this idea of AI DAOs, these DAOs that are infused with some AI smarts, and basically sitting there as sort of bots living on this network, sort of like a good computer virus, sitting there to basically play the transfer of funds. And it's going down this path bit by bit by bit. And they publicly talked about this. We had a conference a month ago on this. And a very quick final example is Ascribe itself. We shipped this in production in February of 2015 after 1.5 years of work. There are more than 10,000 users. Maybe it's not that famous to you people, but it is actually used all over the world in the world of art and digital art by galleries. The National Gallery of Singapore has purchased. Mac Vienna, which is older than Cana, and others use this. It solves a very particular problem of how do I collect digital art, right? So once again, just because you haven't heard of it, or some of you, because it's not necessarily consumer level, under the hood, there's real stuff happening and going on.
I will actually add to one of that land registry in Africa. It's working quite well as well. There's a couple of good firms doing that.
Yeah, we're actually doing that with Ben, yeah.
Yeah, so actually I was about to talk about energy as well. So we're actually also seeing lots of interest coming from the car space, or, well, many things related around cars into cryptocurrency. So we're working with LHoFT from the Netherlands, for example, and they are currently working on a charging station that's actually funded and driven by cryptocurrencies, in our case IOTA. So what's happening here is that you've got your electric car, and at some point these cars will have their own wallets. They will own their own amount of tokens, and you'll just drive up to a charging station and plug in, and the car and the charging station will just figure out the payment and the charging process all by themselves. So that's a very user-facing application for cryptocurrencies that is in production, well, in beta phase right now. Some other stuff, for example, is also with energy. Is they're working on 2 use cases. One is, for example, having having all these charging stations. They own about 1,600 charging stations across all of Europe, and they're also moving these to cryptocurrencies. Then there's a driver log for car fleet management, or going one step further, what I was talking about in the beginning. Companies need to figure out how to have an audit log of their shipping trail, and we're working with the car manufacturer in this at the moment, for example. So there's lots of interest, even successful interest in this. But as Trent said, you probably haven't heard about it, but it's not necessarily so very user-facing.
I just thought of a couple actually consumer-facing things. So the person who was one of the he was actually the inventor of JavaScript, and he was a main developer of the browser, Netscape, Brendan Eich. He has a company called Brave, and they've been building a browser, and it is decentralized. It's got a cryptocurrency to incentivize you to use it, and that actually directly pays the publishers. So you're not going to kind of ignore the inventor of JavaScript and the browser, right? It's probably useful to not ignore that. So that's one example. Another example is Kik, the company. It's a messaging app, and they've got, I don't know, 10 million, 20 million users. And they actually have released a cryptocurrency called Kin to incentivize you to use their messaging app back and forth. And the incentives are basically, if you're using it, you're getting paid, whereas if you use Messenger, then Facebook is people farming you, right? So take your pick. You can either have someone people farming you, or you can use something that's secure and you're actually earning money. Take your pick, right?
And I'm going to finish off with 2 last questions. The first one, I'm not a technologist, so you're going to have to excuse me on this, but I see, and even you guys have mentioned, some overlapping in terms of use cases. There's a lot of initiatives around blockchain targeting exactly the same problems with the same similar solutions. How do these functions going forwards in terms of interoperability? Is anyone dealing with that? Don't they need to be linked together somehow?
So there's a few approaches to actually managing this. There's a startup, or rather, there's something called Polkadot, which tries to achieve chain interoperability. There's also other things happening, for example, things called atomic swaps, where you have tokens on one chain, you want to swap them for tokens on another chain without actually paying in exchange for the trading fees. So people are seeing these issues and are currently working on solutions. In the long run, you'll probably see only a few chains or a few cryptocurrencies coming out as the winners. Who those will be, we'll have to see.
Kind of my view is, if you think about this, everything as the stack, right? Just like the AWS stack or whatever, for any given building block in the stack, file systems say, you've got several competing projects. You've got IPFS and Filecoin competing with Ethereum Swarm, competing with storage and SIA and so on. And the thing is, if you're building, say, a smart contract system with Ethereum, writing some code on top of Ethereum, you can plug into any one of those, right? In the same way that you would write, your JavaScript code to plug into S3, right? And remember, at the core, these things are all protocols. It's a definition of how computer A talks to computer B, manifested in a network, right? And you can have multiple manifestations, like the Bitcoin protocol is being run with the Bitcoin network, the Bitcoin Cash network, et cetera, right? So you have protocols throughout, and they interoperate in various ways as they need. You had mentioned Polkadot, and overall, you can connect networks in terms of state, like Polkadot, in terms of value, like Interledger, or in terms of even just data itself, like good old TCP/IP, right? That is actually a decentralized protocol that gave us the internet to connect networks of networks, right? And I should also add, IOTA and BigchainDB, we collaborate a lot. Just yesterday, I shared the stage with Dominic for giving a talk to a smallish audience, and we actually have an integration back and forth with IOTA and BigchainDB, so that's a wonderful example of interoperability, even within Berlin here. So
I'm going to have to leave my second question for later, I think. We've run out of time. Gentlemen, thank you so much for the discussion. I hope it was as interesting for the audience as it was for me. Thank you for your time. Thank you.
Thank you.